A fan sent 3 metal samples, namely 50 CRV, 60 Ctumen, and 65 Men, all of which are spring steels. 50 CRV is an alloy spring steel with good comprehensive mechanical properties and fatigue resistance. It is often used to manufacture leaf springs and coil springs in automobiles and tractors. 60 Ctumen is also an alloy spring steel with a high elastic limit and good hardenability. It is widely used in shock absorber leaf springs, mechanical springs, and other components of automobiles and locomotives. 65 MN is a carbon spring steel with high strength, hardness, and good elasticity. It can be made into small-sized, flat springs, valve springs, and also used in some wear-resistant parts. Cut the samples into small pieces. Place them in a metallographic mounting machine for embedding. Use a metallographic grinder or polisher to grind the surface. Apply diamond suspension for polishing. After polishing, a mirror-like finish is achieved. Perform surface etching on them. Then start observing with a metallographic microscope. At 200x magnification, the structure is composed of ferrite or perlite matrix and brown carbides, with black dot-like defects distributed. At 500x magnification, the structural details are clearer, and the defects are easier to observe. At 200x magnification, the structure is composed of ferrite and perlite, with many black impurity defects distributed. At 500x magnification, the structural details are clearer, the structural uniformity is poor, and the morphology, distribution of phases and defects are more obvious. At 200x magnification, ferrite can be seen in the structure, along with brown blocky and dot-like perlite, and many black impurity defects. At 500x magnification, the structural details are clearer, the black inclusion defects are more obvious, and the structural uniformity is found to be quite poor. Overall, the metallographic structures of these 3 materials have varying degrees of defects, such as black impurities and poor structural uniformity. 50 CRV has obvious black dot defects. 60 Ctumen has prominent problems of impurities and poor structural uniformity. 65 MN also has impurities and poor structural uniformity. The overall quality of the 3 is poor, which will affect their mechanical properties. In practical applications, it is necessary to consider the working conditions and pay attention to whether the performance meets the requirements. Quality can also be improved through targeted optimization treatments.